All right, this is group number five's answer for question number two. Um, so it's asking how fast like a shadow is of a ball falling from 20 meters is moving. So we get the equation h of t equals 20 minus 4.9 t, and we can get the height instantaneous to the height of the ball with h by plugging in the height at the 1 second, which the question asks of us. X is equal to the distance of the shadow, and we find out that if we plug in 1, h of 1 equals the height at 1 second, which is 15.1 meters. So because the rate of change is the rates of change are related, we can set the expressions equal to each other. So height and distance of one triangle equals the height of distance of another triangle. So 20 over 10 plus x equals h plus x. And we can cross multiply to kind of get a easier to equation that's a bit more easier to process. We get 20x equals 10h plus hx. And also what we can do is find the derivative of the first equation. So we just bring the 2 down to the front and get rid of the 20. We get dHdt equals negative 9.8t. So now we're going to find x. Right here we can plug the known values in of h. So we plug in 15.1 for h. We get 20x equals 151 plus 15.1x. Take away, do some basic algebra, take away 15.1x from both sides, get 4.9x equals 151. Divide by 4.9 on both sides, you get 30.816, and then a bunch of crazy numbers. And then now to find the speed of the shadow, we want to take the derivative of each expression in this first equation, 20x equals 151 plus 15.1x, with respect to t. So we do 20 dx dt equals 10 dh dt plus x dh dt plus h dx dt. And then so you just want to combine like terms to make it a little more easy to process. You get 20 minus h dx dt equals 10 plus x dh dt. You plug in the known values, known variables and values. So we know what x is, we know what h is, and we solve for dh dt up here. So we can, once we plug everything in, we get this kind of expression, 4.9 dxct equals 40.816, etc., minus 9.8t. Divide both sides by 4.9 to isolate dxct, and then it's 40.816, etc., times negative 2t. And then obviously you combine those terms and you get answer of about negative 80.16, excuse me, negative 81.633 meters per second, and this is a downward vector, so that's why it's negative.